So we'll do a quick review of where we left off. I know it's been a while. So we started logs by converting from exponential form to log form. And that was part of our quiz that we took right before we left. You guys did awesome on the quiz. But you know, something like this is in exponential form, and then we converted that here into log form. Okay. And we went back and forth here. Remember, that's the common log of base 10. And so when we put that in exponential form, that would be 100 equals 10 squared. So we started off by doing that. We then talked about what the function of a log means. And this log base 2 of 32 means 2 to what power equals 32? Well, 2 to the 5th is equal to 32. So that's kind of the concept of a log. And then we had 3 rules primarily that we focused on. The product rule, and that was when you are expanding or condensing, that the addition becomes multiplication, as well as the quotient rule, which was that subtraction became division. And then we also had the power rule. So I know that was real quick, but that's kind of a review of what we were doing. So where we are at now is we want to use those ideas to try and actually solve equations. So something like this ugly thing would be really hard to solve without using logs. And I'll show you why in just a second. But let's start with this basic one. 2 to the x equals 32. Now, if you guys remember your powers, x equals 5, right? 2 to the 5th is 32. So we can do that pretty quickly by just knowing our powers. We also could solve this using a log, which I'm going to show you how, because some of them we can't do very quickly. So if I wanted to write this into log form, remember the 2 becomes our base. And so this written in log form is that x equals log base 2 of 32. And again, remember, just to keep proper notation, when you write that, the x, the equals, the log, and the 32, those are all written the same size and on the same line. Okay, this little 2 is a subscript that is written below the others, and it is written smaller. Okay, so this 32 is like not an exponent. Okay, that's written on the same line as the log. Now, this we can plug into our calculator. So let's go to our calculators here. Where's my calculator? There it is. All right. And notice on your calculator that there is a log button kind of towards the middle of our keyboard here. And if I hit that log button, I can type in any base I want. And so we want log base 2 of 32. And I'm going to hit enter. And so x equals 5. And we already knew that, right? We knew that the answer was 5. So you might be saying, well, why is he making such a big deal about this when we already knew that x equals 5? And the reason I'm making a big deal about that is because these were nice numbers. But if you look right below there, if we wanted to solve d, okay, the first thing we want to do is get this 2 to the x by itself. So I'm going to divide both sides by 3. So I get 2 to the x equals 42 divided by 3 would be 14, right? 14 is not a nice number. It's not a power of 2. I know that 2 to the 3rd is 8. I know that 2 to the 4th is 16. So my answer is somewhere between 3 and 4, but I don't know what it is. So I want to write this in log form. So I get x equals log base 2 of 14. And I'm going to use my calculator to get an approximation for that. I'm going back to my calculator and typing in log base 2 of 14. Now notice if I hit enter, it pulls up the same thing because that actually is our exact answer. I need to hold the enter button down and get the squiggles to get a decimal approximation. It is approximately 3.8, which is good. I remember we knew it was between 3 and 4, right? So it is, X is approximately 3.8. Okay, so the logs help us solve these problems where we don't have real nice numbers. That's kind of why we need them. So let's do, I'll skip the middle column. Let's do part C here. We have e to the x equals 7. Well, e is this crazy number, right? What is e roughly again? That's 2.7. It is approximately 2.7. And so I don't know, 2.7 to what power equals 7? I have no idea, but I could write that in terms of log. When you write that in log form, remember that is x equals log base e. Notice I did not write log base e, but wrote natural log of 7. And now going back to my calculator, next to the log, there is a natural log button. So the natural log of 7, I'm going to need to approximate that. It was about 1.9. And maybe we should go to the hundredths spot. So let's call that 1.95. So x is approximately 1.95. All right, so to do something ugly like f, I want to first get this by itself. So do not make this common mistake. We do not multiply 2 times 3 and write that as 6 to the power, okay? Follow our normal orders of operations. We want to first move the -4 over by adding 4 to both sides. So I get 2 times the quantity, 3 to the 2x minus 5 is equal to 15. Again, I got 15 by adding the 4 over. And still do not multiply those. I have to divide by 2. So I have 3 to the 2x minus 5 is equal to 15 over 2. And you could write that as a decimal if you want to. It doesn't matter because I'm going to plug it into my calculator no matter what. So you could write that as 7.5. I'm just going to leave it. But now I'm going to write that in log form. So that's going to be 2x minus 5 is equal to log base 3 of 15 over 2. You guys still with me? Okay, remember this whole thing is just a number. So to solve for x, because this is just a number, to solve for x, I'm going to move the 5 over and divide by 2 to the other side. So that means that x equals log base 3 of 15 over 2 plus 5 all divided by 2. I'm going to plug that in my calculator in just a sec. Okay, because that actually is our exact answer. So I've got log base 3 of 15 over 2 plus 5 over 2. All right, so I got log is 3 over 2. Now I can do this a couple ways. I could type the whole thing in, or I could get my decimal approximation of this. And it was plus 5 and divide it by 2. So I just take that answer, plus 5 divided by 2. That would be one way to do it. You could do it all in one step also, depending on your calculator skills. But our final answer is approximately 3.42. Yes. Okay, so for the question is for the plus 5. So I first did the log base 3 of 15 halves, and that gave us a decimal approximation of 1.834. And then if you just hit plus, your calculator will automatically paste that, and I hit plus 5. So that was 6.834. That was like the 6.834, that's the top of that fraction we had. And then I took that top of the fraction and divided by 2 to get 3.42. Okay. So X is approximately 3.42. All right, any other questions? We're gonna up the ante in just a second. I know, we must carry on, right? We have to do a little more. All right, let's take a look at this problem down here. Now we have something in log form, and we want to try and solve that thing. Well, if it's in log form and it looks ugly, which this does to me, I'm going to try and put it into exponential form. So remember, to condense them, my subtraction is going to become division. I could write the left side as log base 4 of x over 8 equals 0. Parentheses aren't necessary. I just put them there to maybe help you guys. So that's my first step, is I condensed that log. So remember our rules of expanding and condensing. Because now I'm going to write it in exponential form. So x over 8 equals 4 to the 0 power. Four to the 0, of course, is 1, so we're getting there now. I have x over 8 equals 1. And so x equals 8. Yes. I'm sorry, say that again. Yeah, so the 4, it's not just 4, but it's 4 to the 0 power. So remember, anything to the 0 power is going to equal 1. Any other questions? All right, let's try D here, okay? So to try this one, first, I cannot put it into exponential form right away. I have to get the log part by itself first. So I'm going to first have to divide both sides by 2. And I get log base 5 of 3x is equal to 2. Okay, I divided both sides by 2 there. Now let's put it into exponential form. So 3x is going to equal 5 to the 2nd power. Now 5 squared, of course, is 25, which we're then going to divide by 3. So I get 3x is equal to 25. And x equals 25 divided by 3. All right, still hanging in there? Okay, there's one thing that I'm gonna just tell you this right now, and then I think this will make more sense, probably not next class, but the class after. And that is that when you have a log function, you occasionally get an extraneous solution. Here's how you have to check for extraneous solutions. Whatever you plug into the log cannot be a negative number. So for example, 8 is a perfectly acceptable answer, because if I plug 8 in for x, that is perfectly fine. I can take log base 4 of 8. But if I got -8 as my answer, that would be extraneous, because I would not be able to plug -8 in there. You cannot take the log of a negative number. I'll have to explain why when we get into graphing, and and then we'll try and tie that into the algebra. Okay, but the reason I'm saying that is because we would want to take a quick peek here and make sure if I plug 25/3 into there, that is going to be a positive number, so I'm fine with that. Okay, it's not extraneous, but I should check for my answers to make sure I don't get any negative inputs into the log. All right, my plan is to do C and to do F also. So please make sure you guys ask questions, because I'm going to then turn you loose after that. So let's do part C here. So the first thing I want to do is I want to try and get the log part by itself. So I'm going to subtract 5 from both sides. So I have 2 times the natural log of x is equal to -1. And then I'm going to divide by 2. So the natural log of x is equal to -1/2. And now we have to write it in exponential form. Remember, our base is e. So this in exponential form is x equals e to the -1/2 power. That would be our exact answer. And we could get a decimal approximation for that. When you do your homework, it'll ask for either an exact or approximate. Remember, this is not a negative number though. E to the -1/2 means 1 over the square root of e, so it's still going to be positive. And we can check that too. So e to the -1/2. If I wanted to check that in my calculator, e -1/2. Okay, it is of course a positive number, which is okay in our solution set. All right, last one. I'll do F here. The log is already by itself, so I'm going to write it in exponential form. So this is going to be 3x equals e to the second power, where 3x equals e squared. And so x is e squared over 3. That is our exact answer. If we wanted an approximate answer, we would just plug that into our calculator. Okay, so the idea is we're trying to take those skills that we learned before our little break and try and use them to solve these equations.